Okay. In this video, we're going to be exploring the basics of developing a GUI-based Python program. GUI, as in GUI, stands for Graphical User Interface. We've talked about these, but we haven't developed any of our own. Except for turtle graphics, our examples so far have been text-based. That is, we use the console window for both input and output. And even the turtle graphics wasn't interactive. We can only watch the turtle do the animation of the drawing. So a GUI is more often what you're used to. Phony, for instance, has a GUI interface with a point-and-click interface with buttons to push and whatnot. And you're used to these types of environments everywhere. And so now we're going to dive into seeing how we can develop those in Python as well. So I'm going to start a new program here. I'll save it as first GUI. And there we go. And I'm going to start by importing a package called tkinter. Inter as in interface. TK represents the underlying technology that's being used for this, and we can talk about that more later on. But it's the most common GUI development package in Python. We'll start by creating our initial window called tkinter.T_k. That's the constructor that creates and returns a window object that we'll refer to as root. Any given GUI-based program has at least one window that it manages, and within that window you might have lots of different other components, and so the primary window is referred to as the root window often. I can even run it just as is. I'll drag the window that it pops up into our viewing area here so you can see what happens. So this is a separate window, pops up on its own just with that one line of code. I can resize the window. It has a default name in the title bar of TK. We'll change that in just a second. The look and feel of your window may be different. It depends on the operating system. I'm running this on a Mac, so I see the standard Mac buttons on the left-hand side. If you're running this on a PC, you'd see the standard Windows buttons over on the right-hand side. But the principle of it is the same, just the look and feel of the windows and the individual widgets that we end up putting in here will depend on the operating system itself. So I can dismiss that window as you standardly would. So let's now start to configure this window a little bit. I can call various methods on the root object. For instance, I can call the title method and set the title in the title bar. I'll call it my first GUI. And then I'm going to call the configure method, which accepts a variety of arguments, named arguments. We'll use 3 of them here. I'll set the width and the height of this window in pixels. And then I'll also set the background color, and we can just use a standard color string like we were using in Turtle Graphics. I'll use light yellow for the background of this particular window, almost a beige. And then I'll rerun this one again, and the window pops up. And there's my new title in the title bar. I got the background that's a light yellow. The size is initially what I specify it to be, 400 by 200 pixels in this case, but I can always resize it as needed. So now what we want to do is start putting things in the window that we can manage. In Python and tk-enter in particular, we create what we call widgets. I'm going to first create a label widget, tk-enter dot label, capital L label, and that's the constructor of a label object. It takes, again, a variety of arguments, the first of which is the window, the node, the element that you want to put this widget into. So I'm going to put my newly created label into the root window, the only window I have. The other parameters are named parameters. I can set the text of the label. I'll just say hello with an exclamation point. And then I'll also set the font of the label. And the font is specified as a tuple, which just has the various features of a particular font. Like the font family, I'll use Helvetica. A point size of 18, and I will make this one bold. So I've made a label object and given it these various characteristics, told it what the text would be and what font to display it in, and the window in which to display it. Now what I also have to do is do something to make it show up in the location where I want it to be. One way to do that is to call the pack method. And what I'm doing with that is that every window has what's referred to as a geometry manager that dictates how the widgets are laid out within the window. The pack method, if you were to use that, centers the widget on its own row. And we'll leave it at that to begin with, just to see what that has, what that does for it, and we'll update it with a different positioning scheme in just a second. So I run this again. There's the window. There's the label. And a label is not particularly interactive in and of itself, unlike most other widgets have some kind of default interaction. But a label is, kind of as the name implies, there to label something, there to present information without itself being that particularly interactive. So in this case, notice as I resize the window, it keeps that widget, that label, centered, and that's what pack is doing for us. That's what packing the label does. It keeps it centered on its own row. So if we add other widgets, they'll appear on their own row. So let's do that next. So we have a label widget, not terribly interactive yet. So let's add a button. Button equals tk-enter dot capital B button. Again, which window it's going into, the root window. I can give the text of the of what I want the button to actually say, and then also define a font for that one. I'll make this one Helvetica 18, but not bold. And this time I'm going to, instead of just, let me pack it initially and run this and see what we have. There's the window. By packing it, each widget is on its own row and kept centered no matter what we do with the window. And this second widget is a button that I can push, but we haven't set it up to do anything yet. It's not interactive yet either. Instead of packing these, I'm going to position them explicitly now to kind of show you how you can spread these out a little bit more. I'm going to comment out um, the lines that are packing, and instead I'm going to say label dot place, call the place method, and pass in a relative x location 0.5, relative y location of 0.5, and I'm going to anchor it. I'm going to set its anchor using the constant tkenter.center. Let's not change the button's location initially, and let's see what this does. So instead of packing the label, I'm placing it within the window with a relative x location of halfway across in the window, halfway down in the window, the relative y location, and I'm setting the anchor of the label to be the center of the label. By default, the anchor is in the upper left corner of the of the label, and therefore it wouldn't be exactly centered if I don't do that. So let's run this one. So here's the window. Now push me was packed into the window. So again, it's on a row by itself just as it was. But the label is kept at a relative location that's halfway across and halfway down in the window, no matter how we resize the window. And the anchor of it is, instead of being up here at the corner of the H, is in the center of the label, which puts it right in the center of the entire window. So now let's move the push me button into a relative position as well, and we'll kind of switch where the button is in relationship. So label.place, and I tell you what, instead of not label.place, I want to do button.place. And instead of the label being in the center of the window, let's change it so that it's maybe a third of the way down. Halfway across. Relative x is the horizontal distance. So we'll keep it in the center horizontally, but let's take the relative y location down to a third of the window. And then let's do the same thing down here for the button. We'll keep it centered horizontally, but on the y-axis, let's bring it to 2/3 of the way down. And again, set the anchor to tkenter.center. So now the label will be positioned, both of them will be positioned centered horizontally, but the label will be put a third of the way down and the button will be placed 2/3 of the way down. And let's see what that does for us. So there's the relative positions now of the label and the button itself. And again, as I change the size, it maintains that relationship. The geometry manager kind of keeps getting consulted and repositions things as the window gets resized and other events occur. Okay. Let's see what's next. The button doesn't do anything. So let's add an event handler. An event handler is nothing more than a function, which I'll go ahead and put up under the import at the top. And I'll define a function I'll call button pushed. We can call it whatever we want. And whenever the button gets pushed in this case, let's change it so that I configure the label to change its text to be, how about whatever the label currently has as its text, and then concatenate the word hi after it. It starts off with hello, and then every time I push the button, I update the text of the label so that it's currently what the label says, plus a space and then the word hi. But there's no, when is this function getting called? I have to set up the relationship between the button that I want to execute this event handler and the button itself. So I'm going to modify the button constructor here, add yet another parameter to this call, and that's the command argument, the command to invoke when the button is pushed, and that therefore is just going to call the button pushed function that I just created. So now there's a relationship between this particular button and the function, the event handler that I want to handle the event of the button getting pushed. So I call it again. This time now, every time I push the button, it starts off, the label starts off with hello exclamation point, and when I push the button, it updated the text of the label so that it was what was in the button plus the word hi. And if I push it again, I get what was in the button, what was in the label, and then I tack on hi. So every time I push it, I tack on another hi exclamation point. Okay? Every time this button gets pushed, every time I push the button, the event handler is called, which in this case is the button pushed method, and the code is executed and does whatever I have set it up to do. All right, you can name the event handler anything you want, and you can have it do whatever you want as part of that process. All right, let's add a text field. I'll call the variable text field tkEnter dot. There's a couple of types. When you do your reading from this week, you'll discover that there's a couple of types of text fields. One that is for single line text input, and one that allows you to do multi-line. The one that does single line is called entry, an entry. And the only thing we will put in that constructor is the window in which it's going to go. And then I'll do another call to the configure. In this case, all we have to do is place it. We will place the text field that we're adding. Let's see. Let's have it be centered. We're just going to keep these all vertically centered, horizontally centered, and we will put the relative Y position of this one to be, let's say, 3/4 of the way down. Anchor is once again the center. And let's run that as it is. That doesn't look particularly good. So what's happening here? There's my new text field. And note, without doing anything else, I can click into it just like you would any text field in a GUI. I could type whatever characters I want. The push me button is overlapping with that, and the hello label is still up there where it was. And you can see it changing a little bit in terms of the relative position. But what's happening is that the label is still a third of the way down in the window. The push me is 2/3 of the way down, or 0.66, and the new text window, the text field we added, is 3/4 of the way down. So let's actually leave the text field at 3/4 and move these back up. Close that, and instead of being a third and 2/3 down, let's put it at a quarter of the way down and half the way down for the button. Running that. That's looking better. The relative kind of location of those three seems nice relative to each other and relative to the window. Let's see. So I can type information in here, but that in and of itself isn't playing a role in this particular program. Every time I push the button, it's still executing the same function we had set up, which is adding the word hi to the label. But the fact that I can type text into this text field isn't playing a role at all at the moment in this program. So let's modify things a little bit. Let's modify the button event handler to take into account the text of the text field, the text that's been typed into the text field. So instead of setting text, we'll set it initially to hello on the label, but when we hit the button, instead of updating it with what was in there, let's change this as follows. Let's always start the text with the word hello, but then add a space, and then tack onto that with concatenation, string concatenation, the contents of the text field. Text field dot get, a method of the text field to get the text that's in the text field that has been typed into the text field, and then I'll tack onto that an exclamation point. So every time I press the button now, it'll change the text of the label to be hello, and then the whatever text is in the text field, and then followed by an exclamation point. So let's run this again. The layout's looking good. If I type in, let's type in a name, Bob. And then when I say push me, hello Bob. I've incorporated, right, the configure call in the event handler of the button, inserts the name that I've added to the text field so that I'm greeting a particular person. So without rerunning the program, if I just change the name that's in the text field, push it again, then I'm saying hi to Fred. Albert Einstein. Hello, Albert Einstein. Okay, so a text field, obviously a convenient way of getting a particular string, a way of getting input into your program. In this case, one line of text we're using to enter a name. So the interaction with the text field kind of comes automatically by it being a text field, and I can type into it. I can hit backspace or delete to change it, etc. All the things you would normally do to interact with a text field in a GUI, and then access it in my program whenever I need to, in terms of the text that's been typed into the text field. All right, so there's our first GUI. One window, the primary window, which we called root. 3 widgets, a label, non-interactive, just used to display information. A push button, labeled to to our specification and attaching an event handler to it, a function that does whatever we want it to do whenever the button gets pushed, and a text field that allows for, in this case, one line of input. Okay. As part of your reading this week, there's also a GUI widgets overview topic, which not only discusses these widgets, but many other kinds without going into a lot of details. There's a lot more we could say even about these three in terms of how you can configure them, how you can make them look. Buttons, for instance, can have images on them. I can mess around with the exact look and feel of the text that's on them as well. Same thing with labels. So there's lots to be said about the way you affect the tiny details of the look and feel. Note, by the way, that the label has a white background. If I wanted it to blend in nicely with the background of the window that I have already set up, the pale yellow, I could have done that. Lots of different things we can do to affect exactly how the graphical user interface looks. Review those other widgets, in particular, thinking about why you would use a particular widget in one case versus another. And we'll end up exploring some of those in more detail in future videos. All right, there we go.